Okay, start doing this question. All of you will be discussing in 10 minutes. 4 questions. The new paper, those who got this paper in the class, is that third paper I gave you. Those who done answering, raise your hands up in Zoom. Others, we do it. When I gave you the paper, I can remember I gave you three papers, right? Isn't it? So this is the third paper I gave you. If you didn't get it, then I'll check it on the next class. Anyway, start doing this. Those who are done answering all these four questions, raise your hands in Zoom. Okay, your time is up. So let me share the paper in WhatsApp community as well. Hmm. I'll check my document. I shared the what do you call paper as well. Okay. Hi guys. Dun, 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 dun. Assalamualaikum salam. Yes, I have. I'll check Purush. I'll check. Okay. Let's check your answers. Huh? So the first question they have said, give two examples for scanning input devices and secondary storage devices. Okay. Is it Imran? That's it. Particular secondary storage device. Okay, let's check. So what do you call you all know to take these devices. In general, we can call them as computer peripherals. Okay. So you take these computer peripherals that are the devices that you can connect to your computer. Computer peripherals. Okay. These are the devices you can connect to the computer. We can categorize these devices into three categories. And one of the categories is input devices. The other category is output devices. What is the third category? Let's see if you all can answer it correctly. You can send your answer in the chat. Huh? What is the third category? Yes. Perfect. You all can answer in that public chat. Okay. That's easy. Yes, there is nothing. We don't have a category of, devices called processing devices. Like CPU comes as a processing device only, but you don't have there is a category, right? So as a category, the third one which we have is storage device. Yes, perfect. It's the storage device. And out of these three, in this question, they're asking two examples scanning input device. So on the input device, we have pointing devices. One, what do you call it? One type. Another type we have is scanning input devices, right? So to scan something from the environment and enter that scanned data for the computer, one of the device we have is if you want to scan papers, the device we have is flatbed scanner. So using a flatbed scanner, you can normally scan these A4 papers, your what do you call any books you have. If you want to scan those pages in the book all we or passport, identity card, all those stuff, we normally use a flatbed scanner. Apart from that, you all know in the shops, in supermarkets, for every product, there is a type of code known as barcode. So to scan the barcodes, we have a barcode scanner. That's another type of scanner we have. Then sometimes you might notice in certain posters or certain places, they might use something called QR codes. So to scan QR code, we have the QR code scanner. Apart from that, we have what do you call another scanner we have. Now, normally if you take these answer scripts, not in Sri Lanka, but in certain countries, if you take the MCQ answers, they are marked using a scanner called as OCR. Sorry, OMR, optical mark reader. If you're using OMR, those answer scripts are scanned. So that's also a scanner. Apart from that, if you have an image, from an image, if you want to extract the text, you want to scan a text from in a picture, let's say there is some text containing, and you want to extract those or obtain those text, we have another type of scanner called as OCR. Okay. And then if you go for banks, in banks, we have these checks. Okay. So to what do you call scan those, the bottom of the check, there is like a number written, and that's written using a special type of ink known as magnetic ink. So to scan in magnetic ink text, we have something called MICR, which stands for magnetic ink character recognition. So the scanners you all have learned in your syllabus are actually these five: flatbed scanner to scan books or pages or papers or whatever, barcode scanner to scan barcode, MICR to scan those bottom text in the checks, bank check, OMR to scan your MCQ answers and mark them, OCR to scan text from image. Okay, you all have not learned QR code scanner as a separate device. Okay, because I don't think you easy. There are QR code scanners devices, but you don't find them easily. So if you wrote QR code scanner, your answer is correct, but more than giving QR code scanner, give some of these because you will very rarely find QR code scans. What's for MCQ? OMR. I wrote barcode reader and just a scanner. Just a scanner, no marks. So you mention what scanner. By the way, all scanners are input. Yep. See, I put barcode reader as a full form. Full form for OCR, optical character recognition. Could we take mouse? Nope. Mouse is pointing device. Okay. So out of these, if you mention what you called any two answers, then put half marks each for the two. What you called pointing devices. And then they're asking two secondary storage device. So you all need to take this storage device. We have two categories. One is primary storage, one is secondary storage. So under secondary storage, there are several categories. Like you have what you called fingerprint reader is also correct. Yeah, fingerprint reader is correct. And OMR is all used for those MCQ answers. So scan the MCQ's answers and mark it. No, scanning input means input. There is an input device. There's a type called scan device, pointing device, like that. Okay. No, that's not what they're asking. OCR is used for OCR is used to scan text from an image. Now, for example, if I give you this paper, in this paper using your mouse, I can't take this text. So using OCR, I can upload this picture and obtain the text from this picture. That's what OCR is used for, to obtain text from an image. Anyways, coming back to the point, when you take storage device, you all can categorize secondary storage device in three categories. One is the optical storage device. Magnet tape is correct. Yeah, right. So we take the secondary storage devices. We can categorize the secondary storage device based on how these devices are made, like the technology used to make these devices. Only it's categorized. One is called magnetic storage device. One is called optical storage device, and one is called solid state secondary storage device. So under what you call magnetic storage device, some of the examples we have are, we can mention what you call hard disk, then magnetic tape, floppy disk. These are the devices you can mention for magnetic storage. You don't have to categorize this. Out of these examples I'm giving you, any examples you mention, that's correct because they are not being told. They are not told you specifically what type of secondary storage device. So out of these three, or else out of optical storage device examples, we have a CD, DVD, and Blu-ray disc. So out of CD, DVD, Blu-ray disc, if you mention also, is fine. You don't have to mention categorize wise. There is no requirement like that. So Blu-ray disc. And for solid state device, the examples we have, one is flash drive. Flash drive means your pen drives. And apart from flash drive, another example we have is your memory cards. Or else SSD hard disk is also correct. If you just mention magnetic disk here also is fine. It's also fine. Anyways, what I wrote in black color, okay? Any of these examples, if you had mentioned, you can, any two examples you mentioned, again, you can put half marks each into two. Again, you don't have to categorize it, but like I did, any example you mention, you get the marks. What scanner do they use in flight immigration site? Where do they use scanners in flight immigration site? I don't know. Google has some scanning thing, right? Is it OCR? Yes, OCR. Okay. If you have any questions, drop in the chat. We're going for the next one. Okay. I hope you are marking your answers using a red pen or else a pencil. Better mark with the red pen. State three main elements of data communication, right? For communication to happen, there are three things you need. One is a person who is speaking, one is a person who is listening, and one is the thing that's going to take the data from the person speaking to the person listening, right? How do you call the person speaking as? Let's say two people are speaking, they're communicating data. The person speaking, how do you call that fellow as? It's not MIGR, means MICR, magnetic ink character recognition. Yes, as flash drive and pen drive are the same, right? Yes, they are the same. And I have posted the paper in the WhatsApp community. There is actually WhatsApp community for this class. I'll just share the link of that in the chat. Those are not there, you can join. Correct. Okay, the person who is what you call speaking, we normally call them as a sender. How do you call the person who is listening as? Perfect. The person who is listening, we call that as a receiver. How do you call the method the data is taken from the sender and given to the receiver as? The way method or the thing or object or anything used to take the data from the sender to the receiver? That is not mode, that is medium. Mode is wrong. That's called the medium. Okay. So these are the three things, the elements of data communication. No. Next. What is the difference between mode and media? Mode is something, media is something, medium is something. Okay. Mode is basically the, it's like, for example, the way the data is traveling. And then I'll explain it. And media and medium is the same actually. Media and medium, but we don't call as media. We don't call as media. We normally call them as medium. It's actually singular plural something, as I can remember. So medium is again the way, but it's mostly, for example, the technology, which means something like this. If I ask you how you can go to your school, right, from your home to uh, your home, your school, the mediums you have is, okay, the different mediums you have to go from home to school is, you can look, you can go in the bus, you can go in the, what do you call, car, you can go walking, These are different, what you call, mediums you have to go to school. A mode is something like this. For example, when you're going to your school, okay, let's say you can go in the, if you're when you're going to school, there are different routes. Okay, you can go in the payment, you can go in the main road, and you can go in the, what do you call, let's say, highway. Imagine your school and your home is a bit far. Okay, but even though there are different ways you can go to your school, you can go in the payment means, what is it, the, you can see the red color stones in the side, that's what the payment is. Okay, it's not payment, it's pavement. PAVE. Okay, so you can walk in the pay. No, if you take payment, you can't take vehicles on the pavement. On the pavement, you can, if you're going walking to your school, you can go on the pavement. Okay, or let's say you can go to your school in the bike as well, right? Now, if you take highway, you can't go in the bike in the highway. In the car, you can go in the highway. Bus, you can go in the highway, but in the bike, you can't go on the highway. So mode is like that, and medium is like that. In what do you call the practical perspective, but theoretically, what, in reality, what do you mean by mode and medium is, mode is like, how is the data traveling? The data traveling from the sender to the receiver only with a simplex mode, or is the data traveling in sender and receiver both, but only one at a time? That's half duplex. Or is it traveling in both the direction by what you call, at the same time it can travel? That's full duplex. And the mediums examples are different ways you can take the data. So data can travel through, let's say, fiber optics wire. Data can travel through, let's say, Wi-Fi. Data can travel through coaxial cable. Those are mediums or media. Got it? Nope. I wrote source instead of sender. Is that correct? Yes, source is correct. If you mention media here, it's correct. Huh? But correct means I will not prefer that answer, even though I'll give you marks today. Avoid writing media. Okay, next. Recipient is wrong. I mean, I'll give marks now. Don't write all those answers in the exam, sir, because in exam papers, there's always a marking scheme they follow. So just because you know synonyms, don't expect your marking, the person who's marking your paper, to know the synonyms as well. Okay, always make sure you use a generic, precise answer than being writing a bit more indirect answers. Even though your answer is correct, you can't always expect them to mark your answer correct. Okay. So yeah, out of these three, if you had mentioned, what do you call sender, put half marks. Receiver, half marks. Medium, 1 mark. Next. There is one main door to enter security area in a bank complex, and two other doors to enter safe room as shown in the given diagram. Okay, so one door is there to enter into the bank, and two others to enter safe room. Okay, so for example, this is at, what do you call, the main door. And these two are talking about, let's say that, safe room door. Okay. They have fixed a security system to protect it. If the main door and any of the other doors are open, the alarm will ring. Okay. Gate open means 0, 1, it seems. Gate closed means 0, it seems. And alarm is working means 1, it seems. Fine. Draw the corresponding logical circuit to show the above situation. Okay. Now, what happens is we have an alarm system. For that alarm system to work, we are going to go and check three things. Okay. We are going to go and check So they are sort of the word gate and do is referring to the same thing. Okay. So without using the word called gate, I'll use the word do itself, right? So there is one door here. We have to go and check, is this door open or closed? There is one door here. We have to go and check, is this door open or closed? There is one door here. We have to go and check, is this door open or closed? So after we get the data from these three doors, or after checking these three doors only, we can actually, after seeing the what you call the status of these three doors only, you can make a decision on whether the alarm has to ring or not. So normally the things where to go and check to make a decision, the things where to go and check is there at logic gates, the things where to go and check, we call them as inputs. So here we have a logic gate where we're going to have a logic gate where we're going to go and check one data from the let's say we call them as actually sensors here, but let's say from the element A, element B, and element C. There are three things called A, B, C. We're going to go and check each of them respectively, right? Now they have told here for the alarm to ring, what you called if the main door and any of the other doors are open, the alarm will go. Alarm will ring. Alarm goes means alarm will ring. Okay, alarm will ring if the main door and any of the remaining. So you can see main door coming is compulsory. So I'm going to take A as yes, we need A. Along with A, so that means A we are getting. Along with A, we need any one of the other doors. So that means the remaining doors are what? B and C. We don't want both of them to actually ring. We want either one of them to ring, right? So if you want to what do you call generate a signal, or if you want to generate an alert, if either one of the inputs are available, or if either one of the inputs are true, then what is the gate we are used between B and C? There has to be a gate here. And what this gate should do is this gate should go and check, is either B or else C giving us a signal. Perfect. If you want to go and check if either one of the inputs are giving us a signal, for that we have to go and use the OR gate. So between B and C, I'm going to use the OR gate here. OR gate will go and check is either B or C. Make from both of them, at least is one of them giving us signal. So if any of the remaining doors are open, okay, along with any of the remaining doors open, you can see main door also has to be open. So you can see main door and any of the remaining. Both of them are compulsory. Main door and any of the remaining. So like the word and is used here itself. So we are going to check the main door A and any one of the remaining. We're going to connect both of them using the AND gate because they have said main door and any of the remaining. So this is how the alarm is going to work. Anyone have any questions here? So if you had connected B and C to the OR gate, put 1 mark here. If you had connected A and the output of B and C, that is A and B plus C. If you have connected these two for the AND gate, put 1 mark there. Again, the A, B, C all has to be labeled, so that you don't get marks. So that's how the marks is broken down here. Again, if there's any questions, drop in the chat. Okay, so because they have said A, that is main door and is represented as this main door and any one of the remaining. So B and C are the remaining. So one of the remaining and A. Those who have any questions regarding this, let me know specifically what your question is and I'll explain to you. Next. Hamza is dropping a question specifically. I wrote the output also. That's not needed. You get the marks if you have connected B and C to the OR gate and output of that as well as A to the AND gate. That's how the marks is going to be broken down. Next. Draw the lines connecting the matching labels. Okay, let's see. So they have given different values and asking to connect. So we have BCD, EBCDIC, D base 16, 90, 75, blah, blah, blah. Right side, we have different values. Okay, all of them are looking like binary numbers. The last fellow looks like a octal number. Let's see. First, what let's do is let's convert 75, which is number given there. It looks like a decimal number because there is no base, right? So let's convert that to binary and see what is the answer. There is a shortcut to convert to binary. If you understood that, I will not repeat it. Again, I tell you all, this method is not there in the syllabus. So I will not repeat it. If you all want, in the first catch itself, focus and listen to it. Or else I'll go for and after that I'll go for the second method. Okay. So what is the shortcut is when you want to convert from decimal to binary. Okay, when you want to convert from decimal to binary, take the given number, okay, and find the lowest, closest binary place value to it. Now, how do you get binary numbers place values? If you have a binary number like this, place value goes as 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. This is basically 1, 2, 4, 8. So these are binary place values. Huh? These 1, 2, 4, 8, these are all place values of a binary number. Number 1, number 2, number 4, number 8 killer. That's how the binary place value goes. Okay. So if you keep on going like that number with the place values, you get 1, 2, 4, 8. It just basically doubles and go. So 1, 2, 4, 8, 16, 32, 64, 120, it goes. So the number we have is 75, right? The lowest, so number 75 is there in between the place value of 64 and 128. Between these two numbers only, the 75 is there. So when I say to go find the lowest closest 64. So now what I'm going to write, I'm going to write all the binary place values that are less than or equal to 75. So 64, 32, 16, 8, 4, 2, 1. These are the place values that's less than or equal, binary place values that are less than or equal to the decimal number given here. Now, to form that number 75, see what are the numbers that should be added together. So for example, 75 is equal to 64 plus 68 and 64 plus 8 is 72. 72. 72 plus 4 is 76 now. So 72 plus 2 is 73, 74, 75. 64 plus 8 is 72, 73, 77. Yeah. If you add 64, 8, 2, and 1, you get 75. So below the numbers you circle, just write 1. Below the numbers you don't circle, write 0. 75 in binary is equal to 1001011 base 2. Actually, this is how we do the calculation in the mind as well. Sometimes you might notice in certain questions, I might process the answer in the mind. If you're really wondering how do I process the mind, this is how I do it. Anyways, do we have an answer like this? 1001. Okay, they're not given the answer in binary. Fine. Have they given, let's say, is this answer equal to the octal answer given? If I convert this to octal, no, I get a 3-digit number. So it can't be octal number. I'll pause that for a moment. It can be. So these questions don't need working. And this is valid working as well. And yeah, to convert octal, you get these 3 and these 3. You get a 3-digit number. But that's fine. I'll keep that on pause for a moment. Let's see BCD. Is this a valid BCD number? 8 plus 1, yes. Is this a valid BCD number? Ding. Let's see, is the second answer valid BCD number? No, BCD always has to be 4 by 4 digits. So after 4 by 4 digit, the largest number BCD number can have is 1001. So BCD numbers will range between 400 to 1001. And you can see 010. That's going to be 124, 1245. This is correct, but this is wrong. So therefore, second answer can't be a BCD number. Can the third answer be a BCD number? 1, 2, 3, 4. 1, 2. Again, there's no 4 digits. So answer is wrong. Can the fourth answer be a BCD number? Again, no. Okay, I'll tell you how I found out that the first one only is a BCD number. Okay. Focus. Yeah. BCD means binary coded decimal, which means we are going to represent each decimal number using a binary value. So for example, if I have the number 75, okay, I can represent not 75, let's take a different number. Imagine I have a number called 23 or 20, let's say 82. Okay. So if I have a number called 82, I can represent this using BCD. If they ask me to represent this using BCD, the idea of BCD is representing each decimal number. So 8 is one decimal digit, 2 is another decimal digit. I had to represent number 8 in binary and number 2 in binary. That's the idea of BCD. Representing in a decimal number, you're going to represent each and every digit in the form of binaries. So apart from representing each digit in binary, there's another thing you have to follow. One is binary representing in binary. Second thing is each what you call decimal number should be represented using 4 bits. 4 bits means using 4 binary digits. So if you want to represent number 8 in binary, what do you call, again, there are two ways you could do this. You could just convert 8 from decimal to binary. So 2 times 4 is 8, 0 remains. 2 times 2 is 4, 0 remains. 2 times 1 is 2, 0 remains. 2 times 0 is 0. 1 remain here. And you can, like this, also find out, okay, 8 means 1 triple 0. The value of 8 kill, you can figure it out. But apart from doing that, there's another method as well. That is, if you do that method, there's one thing to keep in mind. Now, this method will work for certain, like, I mean, for large numbers, but for small numbers, like number 2, if you want to convert and find, 2 times 1 is 2, 0 remains. 2 times 2 is, 2 times 0 is 0, 1 remains. Now, if you to convert 2 from decimal to binary, your answer is going to be 1 0 base 2. No? So the point is, you can't just convert the number from decimal to binary and keep. You have to convert the number from decimal to binary and you have to keep in 4 bits. Now, here we have 4 bits. So we can tell, okay, 8 can be represented using the 4 bits as 1 triple 0. But if you take number 2 in binary, if you convert to binary, you get 1 0 now. But are we having a 4 different bits? Take 1 0 base 2. Are you having 4 bits there? Are we having 4 binary digits there? No. So tell me, how can I represent, not convert, I'm again saying represent. How can I represent the same number using 4 bits without changing its value? Exactly. I can, what do you call, convert it. I can represent that using 4 bits, 4 binary digits without changing its value by adding 0 in front. Because for a number, if you had zeros in the left side corner, still the value is going to be same. You read this also as 23, this also as 23, this also as 23, this also as 23, right? So when you add zeros in the left side corner, the value is unchanging. So way I can represent number 2 in binary using 4 bits are, one is 0010. This is one of the methods you can tell. So you can tell, okay, 82 in BCD is equal to, what do you call, 1 triple 0 and 0010. This is how 82 is equal in BCD. You can mention. But the thing is, this method is too long, like converting and going. So there is a shortcut for that as well. Just try the 2 digits separately. Below each digit, just write the first 4 bits place values. First 4 binary digits place value 1, 2, 4, 8. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So once you write the first 4 bits place value, circle the numbers you need to form the respective digit. To form the number 2, you need only 2. To form the number 8, you need number 8 only. So below the numbers you need, write 1. Below the numbers you don't need, write 0. So you got the same answer. 1 triple 0, 0010. That's the same answer we got here as well. So this is one method we have. But yeah, both are the same. That's your wish. So how I figured out that the answer number 2, answer number 3, answer number 4 is wrong is, the reason I told answer number 2, 1, 2, 3, answer number 3 is wrong is, always when writing BCD numbers, every number has to be represented using 4 bits, right? So here, if you notice answer L, okay, this has 1, 2, 3, 4, 5, 6, 7, which means if I take, okay, these 4 are representing one digit, you can see balance, I have only 3 bits, okay? But the rule of BCD is what? Every digit has to have 4 bits. So because I have only 3 bits here, I'll be like, okay, this can't be a valid BCD number, because always a BCD has to be 4 bits, 4 bits, 4 bits, 4 bits. That the number has to be, right? So therefore, the answer number L was wrong. That's how I decided L was wrong. And how I decided K was wrong is, in K correctly, we have 4 bits by 4 bits. So these 4 bits are representing one digit can take. These 4 bits representing one digit we can take. That's fine for K. But where the problem in K is going is, if you take BCD, BCD is used to represent a decimal number in binary. Okay. I mean, each decimal digit in binary, right? So if you take a decimal number to form a number in decimal, we have these digits, right? What is the largest number in decimal this each digit can be. If I ask you to write a decimal number, this is 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 a decimal number. Okay, this is a decimal number. These are all decimal numbers now. If you take a decimal number, each of these are talking about digits. This is one digit, this is another digit. This is one digit, this is another digit. This is one digit, this is one digit. These are all digits, right? If you take a specific digit, the minimum value of a digit could be 0. Okay. What is the largest value of a digit could be? Correct. The largest value of a digit could be is 9. Now, if you find how much is 9 in binary, the value of 9 in binary will be 1001. Okay. So in BCD, we say each digit is represented in binary. No? So the largest BCD value could be 1001. Okay. So if you take number 10 in what do you call binary, number 10 in binary is equal to 1010. Number 10 in binary is equal to 1010. Okay. But can we have in one digit the number 10? When I'm writing a decimal number, okay, can a single digit store the value of 10? Now, for example, in hexadecimal numbers, you can. If I write a hexadecimal number, I can write something called A3 base 16. So in this hexadecimal number, the value of this digit is 10. Okay. But if I'm writing a decimal number, can I have a decimal number with a specific digit having a value of 10? Yes or no? No. Okay. That is not possible. So therefore, we say any number that's greater than 1001, that is number 1010, or else 1011, or else 1100, or else 1101, or else fobble 1. These four numbers, if you take, sorry, 1, 2, 3, 4, 1, 2, 3, 4, 5. These five numbers we take, we call them as invalid numbers. Not invalid, there's another name. I can't remember the exact name for that. But it's called invalid name, illegal though. There's one word that I can remember I taught in the class, but yeah, there's a word that we use. So you can't use those numbers for BCD. That's the idea, right? So the reason I said K is wrong is because in K you can see 1100 has been used. You can't have 1100 because 1100 represents the value of 12. A specific decimal digit cannot have a value 12. The largest value a specific decimal digit can have is 9. As forbidden numbers. These are called forbidden numbers. Even though you can represent these numbers using 4 bits, these can't be taken to represent BCD values. Okay. So the reason I said what you call the answer K is wrong is because in K, the first 4 bit is representing a value of 12. And 12 cannot be represented using a single decimal number. And same reason for M as well. M, if you take 1101, 1101 represents the value of 13. You can't have a digit with a value of 13. I will clear now why K, L, and M are not suitable for BCD numbers. If you have any questions, drop in the chat. Huh? Drop your question in the chat. Don't go and just reply saying, I don't understand. Tell me what you don't understand if you don't understand anything. Okay, next is D base 16. So D base 16, if you convert that, let's say, to binary, first of all, you should know what is the value of D. Tell me, D is a hexadecimal digit. No. What is the value? It's a letter, right? But even though it's a letter, the letter holds a value. What is the value letter D is holding in hexadecimal numbers? Like in hexadecimal, A is equal to 10, B is equal to 11. That you know, right? That's how you represent a number. Yes, Surendra. Is it because we take each number individually that we can take the number 10 as BCD? Not we can't take number 10 as BCD because we take each number individually. So like we take each individual digit and convert it to binary. Each individual digit and convert to binary. So this digit's largest value it could contain is 9, right? So we convert 9 to binary, it will be 1001. But a digit, can it hold number 10? A specific digit can't hold 10. If you have a number 10, it's like 10. Perfect. Exactly. D means 13. So if you convert 13 to binary will look like 1101. Okay, there are two ways you could convert from decimal to what you call, you can convert the number 13 to binary. Okay. Um, I'll tell the easiest way. The easiest way is you take the number. So this is basically hexadecimal to binary. The easiest way, if you know what do you mean by hexadecimal, if you know the idea of what is the meaning of the word hexadecimal, it's very easy to understand the idea of how to convert it. Hexadecimal is a number string that was created to shorten binary numbers. Same thing is a history behind octal as well. If you are coming to my class, you all know I have been repeating this 1,000 times. Okay, octal and hexadecimal, how they were made was to shorten the binary numbers. Octal shortened the numbers into 3 bits by 3 bits. Hexadecimal shortened the numbers by grouping the whole binary number into 4 bits by 4 bits, which means these four binary digits are going to represent one hexadecimal digit. These four binary digits are going to represent one hexadecimal digit. Likewise, how do they shorten the binary numbers? They group four binary digits together and they gave a value for it. Grouped four binary digits together and they gave a value for it. That's how the whole conversion works. Okay. So when you take the number given there, D base 16, you can see there is a single hexadecimal digit here. Now, based on this idea of grouping, if you have one single hexadecimal digit available, behind this one digit, how many bits are hiding? Hana, if you get a number called 10, and if you want to convert 10 to BCD, what is the idea of BCD? Converting each digit separately. So to convert number 1 to binary, convert number 0 to binary. So if you convert 1 to binary, you'll get 0001. To convert 0 to binary, you get 400. So number 10, 10 base 10, if you convert to binary, that's basically 0001. Sorry, BCD 0001, 400. Got it? Exactly, 4 bits. So that means behind this letter called D, there are 4 bits hiding. So we have to figure out what those 4 bits are. So to figure out what those 4 bits are, easiest method is write the first 4 bits place value and see to get the number 13, what are the digits that should be added together. So 8 plus 4 plus 1 is equal to 13. Below the numbers you need add 1, other number 0. So answer is 1101 base 2. If you go and see, do we have a number called 1101? Yes, we do have. So D has to be matched with that. D has to match with 1101. Okay. Next, we have 75 EBCDIC and 90. Okay. So the idea of EBCDIC is you're going to represent each digit using 8 bits. Okay. So do we have a number with 8 different bits? K having 8 bits. So EBCDIC and K can be matched. But why didn't 75 get matched yet? 64 plus 8 is 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. 100 1 0 1 0 1. Let's see. So normally, if you take what do you call EBC DIC coding system, here what happens is you're representing each number using 8 bits. Sorry, so if you go to the answers given here, the second answer has 8 bits. Therefore, you can take that here. Multiples of 8. Okay. So BCD is the number should be having multiples of 4. ASCII, the answer should have number of bits equal to multiples of 7. EBCDIC, the answer, the binary number should have digits of the multiples of 8. And Unicode should have digits with the multiples of how much? In Unicode, each number is represented using how many bits? Or each digit is represented using how many bits? How to decide whether we should convert the given number to binary, hexa, or octal? Because all the numbers given here looks like binary, even though they have not mentioned the base 2, it looks like binary. That's why I converted binary. Yes, Unicode is 16 bits. So Unicode, if you have a number in Unicode, obviously the answer will be in multiples of 16. So yeah. So the second answer has 1, 2, 3, 4, 5, 6, 7, 8. That's why I wanted to match that. Now we have 90 and 75. Let's convert 90 from decimal to binary. To convert 90 from decimal to binary, um, 64, 32, 16, 8, 4, 2, 1. 1, 2, 4, 8, 16, 32, 64. Yeah. So 64, 65, 66, 76, 86, 96, 64, 70, 80, 88, 89, 90. So 1, 1, 1, 1, 0, 0, 0. Answer is 1, 0, 1, 1, 0, 1, 0. Yeah. So if you convert number 90 to binary, that's equal to 1, 0, 1, 1, 0, 1, 0. So these are answer matching. 75, 93. Let's double check and see 75 equal 93. 8 times 8 is 64. 8 times 9 is 72. 72. And 3 remains. 8 times 1 is 8. 1 remains. 8 times 0 is 0. 1 remains. Exactly. 113. I think that's a printing mistake. I told you earlier itself, it's a 3-digit number killer. So what do you called? A cannot be matched to 70, 93 unless 75 is different base. Okay. So given based on given answers, this is how it works. Can you show how to get the answer? You mean how to get this answer? That 10111010. Then D. Here. Just convert from for if you have hexadecimal number, if you have, for example, this is a single digit hexadecimal number. But imagine you have 2D, like for example, let's say we had an answer called 2D base 16. Step number 1, take both the digits separately. 2 is one digit, D is another digit. Step number 2, below each digit, write the first 4 bits place value. That's 1, 2, 4, 8. Why I'm writing the first 4 bits place value is because I want to represent number 2 using 4 bits. Why 4 bits? Because hexadecimal is basically shortened form of binary in 4 bits. I told you the history of how it works. So to get the number 2, you need 2 only. To get the number D, D is equal to 13. So 8, 9, 10, 11, 12, 13. Below the numbers you circle, write 1. Below the numbers you don't circle, write 0. So if we convert from 2D base 16, if we convert to binary, your binary answer will be 0010, 1101 base 2, right? So here it's a 2-digit number. Here is a single digit number. So what I did is below the D, I wrote the 1, 2, 4, 8. Circle the numbers I need to form the respective number. Below the numbers I need 1. Below the numbers I don't need 0. And that's how I found it. ABCD question. The ABCD question is, if you take BCD, BCD is a coding system where you represent a number, okay, using, or you represent values using 4 bits each. So for example, if you want to represent the word called hello, you can't represent the word called hello in BCD. But if you want to represent a number called, let's say, 231, to represent number 231 in BCD, you'll have to use 12 digits. To be more specific, you'll use 12 bits. Because why? In BCD, each digit is represented using 4 bits. So 2 is represented using 4 bits, 3 is represented using 4 bits, 1 is represented using 4 bits. Total 12 bits will be there. Similarly, in ASCII, each digit is represented using 7 bits. Now, ASCII, you can represent letters as well. So if I ask you to represent number 7, hello in ASCII, H will take 7, E will take 7, L will take 7, L will take 7, 0 will take 7. So 7, 14, 21, 28, 56. So 7, 14, 21, 28, 35. What do you call? This number will have 35 digits, or to be more specific, to represent hello, you need 35 bits. Indirectly, in ASCII, each digit is represented in 7 bits. BCD, each digit is going to be represented in 4 bits. So always an ASCII BCD value will be the multiples of 4. ASCII value will have the number of digits equal to multiples of 7. And EBCDIC, each digit is going to be represented using 8 bits. So if each digit is going to be represented using 8 bits, if you take a EBCDIC number, always the EBCDIC number will have number of digits equal to multiples of 8. If it's one digit, it has 8 bits. If it's two digits, it has 16 bits. If it has three digits, it will have 24 bits, right? And Unicode, each digit is represented using 16 bits. So a single digit value will have only 16 bits. If you're going to represent the word called high in Unicode, it will have a total of 32 bits here. So always a Unicode value will have number of bits. If you take in Unicode, it will always be the multiples of 16, EBCD multiples of 8, ASCII multiples of 7, BCD multiples of 4. Got it? So the reason I chose for ABCD is I chose second answer is because second answer has 8 bits, which is a multiple of 8. How or why do you take 75 as decimal? When a number doesn't have a base, we normally consider the number to be a decimal number. That's why I considered 75 as decimal. Umair, first one, yes. Second two, I didn't. I need a full form to actually know it. Is that two zeros in front of the final value important? Yes. In decimal to hexadecimal, no. Sorry, hexadecimal to binary, no. Yeah, basically number conversions, zeros in front is not important, or number system conversions. But coding system conversions, those numbers are important. So EBC, BCD, ASCII, Unicode, blah blah blah. These are all called coding, different coding systems we have. So here, if you have a zero in front, yes, it is important. But apart from that, in the number systems, that is like binary, octal, hexadecimal, decimal. Here, if you have zeros in front, you can ignore. Only if needed zero. Next. So yeah, so that's in that question, what you called A is wrong. So you have to ignore A. Okay. And I don't mind what you do with A. I'm not giving marks for A. So if you correctly matched B with J, put half marks. If you correctly match C with M, put half marks. If you correctly match D with K, put half marks. If you correctly matched E with L, put half marks. And now put so total 2 marks there, okay? So out of 8 marks, now tell me how many marks you got in total for row number 1, 2, 3, and 4. We can consider L as ASCII code, right? No. Nicely open your eyes and tell me where can you see 7 bits here? I can just see one letter here. Can you see 7 bits here? I can see only one letter here. To consider value to be ASCII value, that a value has to have 7 bits, which means 7 binary digit. If it doesn't have 7 binary digit, it's not an ASCII code. Okay, Hannah. You can represent the letter L in ASCII. Yes. If you represent letter L in ASCII, it's going to be, I'll do the questions. And I'll show that at the end, okay? Okay, we have not still learned about HTML, so I'll pause this for a while. Mm, that's an easy question. Ask me that. We have 20 minutes. So I can do I'll give you 5 minutes. Do the question number 7 and 8 only. Yeah, then I can discuss in 15 minutes. EBCDA stands for Extended Binary Coded Decimal Interchange Code. Depends on the question number. Those are done, you can raise a hand in Zoom. I doubt if we can discuss both. Well, let's see. I'm a bit on time. Just now I noticed. Or if I use your brains and tell me, is this a valid octal number? Is 93 base 8 a valid octal number? I'll pause the timer for you all. Let me pause the timer first of all. Is 93 base 8 actually a valid octal number? Keep away the answer correct or something. No. Why? It's not hexadecimal. Base 8 is octal. So it is octal number. But even though they have planned to represent octal, 93 as a number is invalid. Why? Because there is 9. So why? What is the problem if there is 9? Exactly. Asa, correct. Perfect. The largest value or largest digit. Okay, the largest octal digit could be 7, not 8, it's 7. Okay. Octal numbers always range between 0 to 7. So 9 is a number that's greater than 7, right? So you can't have octal, this is an invalid octal digit. Okay, I'll again resume the timer to this question order. वो बकर WhatsApp. Okay, your time is up. Let's check your answers. Copy the given truth table to your answer script and complete the truth table relevant to the given logic circuit. Let's check your answers. So in this question, they have said, they have given here a circuit with three gates. We call this gate as a NOT gate. We call this gate as the AND gate. And we call this gate as the OR gate. Right? Yes, Atika. You can go ahead. And then, if you look at this NOT gate, the input for the NOT gate is coming from A. So if A is coming as the input for the NOT gate, then the output is going to be A dash. If you look at this AND gate we have here, for the AND gate, the input from the top is A dash, the input from the bottom is B. So the output, how we define is, first of all, we figure out what are the inputs we have. A dash is one input, B is one input. AND gate, what we do is in between our inputs, we mention the dot symbol. So the result of this AND gate is going to be A dash dot B. Then we have here the OR gate. For this OR gate, the input from the top is coming from A. So I write A as it is. The input from the bottom is the output of the AND gate. So what is the output of the AND gate? A dash dot B. So one of my input was A, other input was A dash dot B. Normally, when your input has more than one character, I have told you all you have to add something. What do you add? Perfect. If your input has more than one character, you're supposed to add the brackets. So A is one input, there is no need for bracket, but A dash dot B, it has two characters. So for this input, the input that's coming from the bottom for this OR gate, this input has more than one character. So therefore, we're adding what do you call for this input, we're going to add a brackets because there's more than one letter for that. Then what do you call in between the inputs? So for this OR gate, if you take one of the input is A, other input is A dash dot B, OR gate in between the inputs, we mention the plus symbol. So the result is going to be something like this. Okay, now let's do the fill in the blanks. Okay, so we have A here, B here, not A dash, not A uh, and B. F is equal to A or not A and B. If you want to refer about, if you are figuring out what are coming in those blanks, the letters and or and is only coming. Okay. Anyways, basically this is representing this. See, not A and B. This is representing A, plus is representing O. So A plus, not A and B. And if you look at this circuit we have here, for this circuit there are two inputs. A is one main input, B is another main input. And if there are two inputs, you all know, each row is representing something called as a situation, or each row is representing a unique input combination. So you can figure out how many situations are there, or you can figure out how many unique input combinations, or indirectly you can figure out how many rows are there using this equation of 2 to the power the number of inputs. So here we have two inputs. So if you have two inputs, the number of rows are going to be equal to 2 to the power 2. Replace the letter n with number of inputs. So we have two inputs. which means there could be 4 rows in this table. That's why, nice to see here, this table has exactly 4 rows. Again, that's already done for us. So that calculation is unnecessary here. Then how you start filling this is you go for the right side corner input. A and B are two inputs. On my right side corner, the input I have is B. I fill this in the pattern of 0, 1, 0, 1, 0, 1. Until I just go in that pattern until the last row. Then I go for the next input and double it. So here I'm going 0, 1, 0, 1. No. Here I go 2 zeros, 2 ones. Now if there was another input, I'll have to go double of that. Double of 2 is what? 4 zeros. So 4 zeros and 4 ones. Killer. That is a pattern of how you go. You double, double, double and go. Start with the right side corner input and double, double and go until the last corner input you have. And that's how you fill the input columns, right? And then what do you call not A and B? So how that works is this not A and B is representing, this is not A and B, A dash dot B. I'll tell you a shortcut of how you can easily figure out this with like forget about logical stuff, and you can easily figure out this. When you say A dash, we are saying the opposite of A. Okay. In the first row, the value of A was 0, right? So opposite of A is going to be how much then? As per the first row, A is 0, right? So A dash means opposite of A. So based on that, what is the value of opposite of A? Correct. The opposite of A is going to represent number 1. So I write 1 here. Then B is represent in the first row, the value of B is 0. So we are talking about 1 dot 0. Now 1 dot is represented AND gate. So using AND gate's logic tell me if one of the input is 1, other input is 0, what will be the overall result? Perfect. The overall result is 0. So I'm going to write here 0. Now let's go for the second row. As per the second row, when you say A dash means opposite of A. So what is the value of opposite of A? In the second row, opposite of A means? Perfect. Opposite of A means 1. 1 dot B. B is representing how much in the second row? Second row. Yes, in the second row, the value of B is 1. See, in second row, the value of B was 1. So I had 1 there. Now using AND gate's logic tell me 1 dot 1. That means if both the inputs are 1 for AND gate, what is the result of the AND gate? Perfect. That's going to be 1. Because AND gate goes and checks, are all the inputs 1? That's how AND gate works. Now let's cover third row. In the third row, A is 1, B is 0. So when I say opposite of A, what is the value of opposite of A as per the third row? As per the third row, opposite of A is how much? Perfect. Opposite of A is representing 0. 0 dot B. In the third row, what is the value of B? 0. So for the AND gate, if both the inputs are 0, what is the overall result? Perfect. That's going to be 0. Now we come for the last row. As per the last row in the truth table, A dash means how much? Perfect. That's 0. B is equal to, as per the last row, B is equal to 1. Now between 0 and 1, we have the dot representing the AND gate. So for AND gate, if one of the input is 0, other input is 1, what will be the overall result? Perfect. That's going to be 0. And that's how I fill the third, what do you call the column. Now we go for the next column. Next column is talking about A or not A and B. So A or means plus or open brackets, not A. Not A means A dash and B, A dash dot B. Again, I'll just replace each of these, what do you call numbers, each of these letters with the respective values. Okay. And A is equal to 0 as per the first row. A dash is equal to 1 because opposite of A means 1 as per the first row. B is equal to 0 as per the first row. Now you might be wondering, what should I do first? Should I go for the OR gate or the AND gate first? Or how is the order? When I want to check that method I was doing, how the order works is, first of all, you go and simplify the brackets. Then you simplify whatever is there in the NOT gate. Then you simplify whatever is there in the AND gate. And finally, you simplify whatever is in the OR gate. So these are order you have to follow. So if I go in this order, I go for the brackets. So if I go in these brackets, there are two things in the brackets, the NOT gate, and actually you will not figure out the NOT gate once you come to this state, I've already done the not gate actually. But if I'm going to take the not gate as a, what if there's no brackets? If there's no bracket, then you directly go. I mean, these are order, man, general order. Like, BODMAS and you're doing mathematical question, right? Just like BODMAS, the order in simplifying this. So if I'm going to like make it a bit more broader, just representing only the letters, it would be someplace. A is representing 0. This should be 0 dash dot B. So the 0 dash, sorry, 0 dash dot 0. So 0 dash represents 1. So you can write like that as well, but that is an unwanted step. Without doing that, directly you can mention the value of A is what do you call 0. Plus is as it is. A dash means opposite of A. If A is 0 here, opposite of A is 1. Dot B. B is 0. Now you focus on the brackets first. So if you go inside these brackets, you can see the AND gate is used. As per the AND gates, if one of the input is 1, other input is 0. AND gate logic, AND gate goes and takes is all the inputs 1. So this is one of the input for the AND gate. Not 0 is another input. When you go and check, is all the inputs 1? No. So no is represented using 0. So again, I take this 0 down. So it's 0 plus 0. OR gate goes and checks is any of the input 1. Now AND gate goes and checks all the inputs 1. OR gate goes and checks is any or is either one of the input 1. So if you go and see the right hand side and left hand side of this plus symbol, is any of the inputs 1? Again, no. So result of this is going to be 0. Not BODMAS, when brackets, not AND OR. That's the order to follow. Okay. Is it wrong if you wrote dot instead of AND in the table and plus instead of OR? You're not going to get marks for that, man. Don't worry. Whether you wrote AND here or you wrote dot here, you're not going to get marks. Did I tell you all the marks breakdown? No, no. There is and method and down either plus down either method and down dot down is not going to give you marks. Okay. Even if you write that wrong, you're not going to get marks. That's how. You could have just checked the first and third column. Yeah, you could have checked the first and third column. I'm just showing you a new method, man. Okay. Anyways, that is one method you could follow in order doing questions. So using that method, you don't have to have for each column. For each output, you don't have to have one separate column. You can have the logic gates. That's the first column. With the only with the inputs one column and the final output one column. So if you're going to have just only these 3 columns also, you will get the marks. And if you're going to do that, then this is the method you have to follow. Got it? Next. So second row, again, what do you call second row? 0 and 1. So 0 and 1 are the inputs for A and B respectively. There, if you're going to find what is the value of A plus A dash dot B, because this is representing A plus A dash dot B, no? So without what you call going in this long method again, you can just take the value of column A, which is this. You can take here the value of column A dash dot B value, and you can compare them. Okay. So you can see the value of A column. Sorry. The value of A is there in this column. The value of A dash dot B is there in this column. So you're going to compare both of this using plus operator, where plus is representing the OR gate. Okay. So you're going to compare the blue color column and the green color column and check is any of the input, because OR gate represents is the idea of any, or else either, right? You're going to go and check is either one of the inputs 1. You compare these two and see is either one of the inputs 1? Yes. You compare this and this is either one of the inputs 1? Yes. You compare the last 2 rows and see last row and see is either one of the inputs 1? Yes. So the final result is going to be 0, 1, 1, 1. That's how the final answer is going to be. Anyone having any questions here? What else, Amar? So what do you call the marks will be broken down like this? We're getting this column. Sorry. When A was 0 and when B was 0, if not A and B was 0 and A or not A and B was 0, if this first row is correct, if your first row is correct, half marks. If your second row is exact like mine, half marks. If your third row was exactly like mine, half marks. If your fourth row was exactly like mine, half marks. Again, you can mess up the row order. Sorry, you can mess up the row order. That means you can what I wrote in the first row, you can write in the second row. What I wrote in the second row, you can write in the first row. You can mess up the whole row order. But when A is zero, how you check your answer is when A is zero and when B is zero, final answer has to be zero. When A was one and B was one, F has to be one. So that's how you check your answer. So like that, you check and put half marks each. Put half marks each and tell me out of 2 marks, how many marks you got here. That is not the scene, man. Amar. There's something else which you're not noticing. Your brother has translated it to you wrong. Can't we change the column A column to B column? If you change that, your answer will be completely different. If you change that, you will not, your last column will answer will also change. You will not be getting same as my answer. So if you change that and you got the same as my answer, then I have to double check your answer. I don't think you'll get the same answer. Again, you're seeing something wrong, Amar. You're seeing up, see down. Anyways, as six is passed, what do you call I'll be discussing Roman number eight question next week. But anyone have any questions today? Okay. So because Variko 6 is passed, I'm going to stop the paper discussion here. But those who have any questions or can stay and ask. Others, people are clear what we learned today or can leave. I have shared the paper in the group. So those who don't have the paper for now, you all can check there. But anyways, my class friends, you will be getting the printed paper ASAP if you have not got it yet. You're still seeing something wrong. Good job, Agnesh. Last display is for pseudocode. Let's see. Yeah. Yes, I also. These are signal I can give you. Anyone have any questions? So I think some of it I said to ask the question at last, will answer. We told you to change the time to 5. Ah, yes, I forgot. From next week onwards, the class will be at 5 actually, from 5 to 6:30. Shit, I forgot to inform that prior. I'll post a message in the group regarding that. Yes, Sanya, I think you messaged me regarding that. I'll check and reply. As I can remember, yes, Nizla, I'll again inform Sonic. Keep send, only the program booklet, right, Nizla? Hmm. Okay, just inform her. Last Monday, Sarah. Hmm. Well, again, this WhatsApp to this number. I'll ask Mr. Rashid. No, because Salma, they have said X equals Z. So in that case, if Z was 4, X will get the value of Z. That's how that X became 4. I'll explain that question next week. There are two ways you could get the answer. I'll show again both the ways. One way is using this equation. Okay. This equation, you replace the value of A and B with the respective values. That's one method. Second method is you use the respective columns. Like for example, here when we have the word called uh I mean here we saw the value of f is equal to what? F is equal to a plus a dash dot b, right? We have one column called a here, the green color highlighted column. Then to represent a dash plus b, we have the blue color highlighted column, right? Because blue color highlighted column is representing a not a and b. It is a dash dot b. So we're going to compare these two columns. The green color highlighted and blue color highlighted. We're going to compare those two using the plus operator, where plus is representing OR gate. So which means I'm going to compare first to the first column and the second column, and I'm going to check is either one of these two columns, okay, having one. Row by row, I'm going to do the comparison. So if I take the first row and compare the value in the blue column and the green column and check, is either one of the inputs having one? No. If I compare the second column and check, is either one of the inputs having one? Again, no. So yes. Second column, second row, yes. Third row, if I go and check, is either one of the inputs having one? Here and here. Again, yes. Fourth row, is either one of the inputs having one? Yes. Hmm. Anyone having any other questions? Not exact regarding this question. Even in one of the previous questions I explained, if you did not understand, you have any doubts. Any doubts you'll have, you can ask now itself and get it clarified. There's no doubts I in the meeting, that's why I'm asking. Okay, so as there's no other particular questions, I'm going to wind up. If there's anything, you can WhatsApp me and get them clarified. I know I have not replied some of the messages, but yeah, I'll get back to you soon. Have a nice day. Bye.